Hi and salam everyone. Welcome to Electronics and Control channel. I am Ghulam Shabbir. In this short video, in this small video, we are going to talk about how to experiment on a series circuit. This experiment will involve two phases. The first phase will be an experiment on a series circuit containing one voltage source and three resistors connected in series with the voltage source, and then another experiment that will involve four resistors and a voltage source connected in series with those four resistors. In the first experiment, we will measure current and we will demonstrate that in a series circuit, same current flows through every component of the circuit, and then voltage divides across all the resistors, and the voltage available from the voltage source is divided onto all the resistors, and the voltage will also be measured across every resistor. And in the second phase of the experiment, where four resistors will be used, we will measure the voltage across every component. Now, since this is software and we can have as many ammeters and voltmeters to be available on a single screen, so we can perform these two phases of the experiment in a single go. How can we do that? Let's start doing that. So as I just told you that we are going to experiment on two series circuit, one containing three resistors and a voltage source, and the other containing four resistors and a voltage source. So let's begin collecting relevant sources. Okay, now let's go to the sources group into the family of power sources and select DC power. We are going to experiment with 12 volt in both of the phases of the experiment. So I have selected this one, and also I can have another voltage source from the library, but we can also make a copy of this source. So I am selecting this one. I will press Ctrl C, and then I will press Ctrl V. Now we are having another source. Okay, now let's begin forming our circuits. Okay, now we need to have two set of resistors, three resistor connected with voltage source V1 and four resistor connected with other voltage source. So I think let's commonly available resistors, select 1K resistor, and then another resistor, let's say it should be 2.2K. Where is 2.2K? Here it is, 2.2K. We can rotate this resistor by pressing Ctrl plus R at the same time, and then finally we need to have a 3.3 kilo ohm resistor. 3.3 kilo ohm resistor. Let's find it, and here it is. Okay, I'm going to close it, and then I'm going to select all these resistors. Sorry, let's make selection box a little bit away from voltage source V1. Press Ctrl C and then press Ctrl V, and here we go. Okay, so let's arrange them, and also we need another resistor to be included in this circuit. So let's choose that one. Going to resistors, and then we need another resistor which should be of 6.8 kilo ohm. I'm just selecting these resistors. You can select your own values according to the conditions of your own experiment. So here we go. I need to align it vertically. So I just aligned it vertically. Now we have everything here except for the meters that need to be connected in circuits. Okay, first let's complete this first experiment, and also we can have some text labels for these experiments. For instance, if we want to call this circuit experiment 1, or like experiment 1A, we can place a text indicating this information. So if we uh, right click and sorry, if we go to place menu, and if we go to text here like this, then my pointer, which was mouse pointer, it has converted into a cursor sign. So if I click here, a text box will appear like this, and I can write in this text box. I can write here experiment experiment 1A. Okay, then I mean, it's now we can edit this text also. So I'm selecting this one. I'm making it a little bit bigger by making it bold, and let's say increase the font size to 12. So I think now it looks fine. And if you want to change the color of the font, you can do that by selecting appropriate color of your choice. So this is experiment 1A. Now you can copy this text. So I have selected this text by clicking on it. I will press Ctrl C, and then I will press Ctrl V. So here is the text. We can place this text somewhere like here, and then we can double click it to edit it, to indicate that this is the second part of the experiment. This is experiment 1B. Press click somewhere outside of this box, then our editing and entering the text phase is complete. Okay, finally now we need to add meters in the circuit, and we need to align the arrangement of these resistors accordingly. So I'm moving this voltage source on left hand side. I'm moving this resistor on this side, and I'm picking one ammeter from toolbar here, and I mean this will measure the current through all the components. And to run this circuit, we must attach a ground connection with it. Okay. Or now we need to measure the voltage across every resistor, and that means that we need to place a voltmeter across every resistor. So this is the set of voltmeters. We can choose appropriate ones. For instance, if we select this one, this can be connected across R1 like this. Let's move this resistor towards the right side to get a proper shape. Okay, now you should see that the name of, or the properties of this voltmeter, they are a kind of messing with the name of resistor R1. So I mean, this is creating a kind of mess onto your schematic. So you can remove this mess. So by double clicking on this, you can go to display tab and then choose use component specific visibility, and then uncheck everything that is shown below. Click OK. Now you can have a very uh, clean kind of voltage, I mean voltmeter. You can make copies of this voltmeter such that you have a clutter-free voltmeter to be connected across every other resistor you need to connect with. So I'm just selecting it. I made a copy, Control C, and then I'm just press Control V. Now I need to rotate it. Oh no, I cannot actually use this like I need to select another one. I need to select a voltmeter which is vertically rotated like this one. Place voltmeter which is in vertically oriented. So I will select this one. I can double click on it. Again, we can edit its display properties such that our circuit looks neat and clean, and just connect it like this. Okay, finally we need another voltmeter to be connected across R3. So let's pick another voltmeter which will be oriented like this. Okay, again double click on it, and now you can change that. Okay, I think we are done with the configuration of the circuit for experiment 1A. Now let's configure the circuit for experiment second part of the experiment. So I'm going to arrange the resistor, let's say rotate it and place it vertically like this, and move this text down, and let's complete the circuit. The circuit is completed. Now we need a ground connection such that circuit could run. So here is our ground connection, and finally we need to place voltmeters across every resistor in the circuit of experiment 1B. So we can copy this voltmeter to be placed across R1. Similarly, this would be appropriate to be copied and then placed across R5, and we can make more copies of this to be placed across R6 and R7. And here we go. Make the connection and just click the run button. We are done with the measurement of required voltages and current in one go. This is the beauty of this software, that it gives you a real-time feel of working in a lab, and it gives you everything in one go. Now let's click run, and here we go. You can see that the current passing through all the components in a series circuit is the same, and this is 1.847 milliampere. Voltage across all the resistors is different, since all values of these resistors are different. This is 1 kilo ohm resistor, 2.2 kilo ohm, 3.3 kilo ohm, and here the situation is a little bit different because you are having four resistors connected in series, and since the voltage 12 volt is to be divided across all the resistors, so the voltage across all the resistors is different. So this is how you can experiment with DC series circuit using multisim. So if you think that this video was interesting for you, please consider subscribing this channel. And thank you so much, and keep watching for more experiments. Thank you so much.